can the interference pattern be produced by two independent monochromatic sources of light? Explain. It is not possible because sustained interference pattern cannot be obtained. Light waves emitted from a source undergoes abrupt phase changes in times of the order 10 to the power of minus 10 seconds. So light from two independent sources will not have fixed phase relationship and will be incoherent. Okay. Next, the intensity at the central maximum O in a Young's double slit experiment setup shown in the figure IO, if the distance OP equals 1/3 of the fringe width of the pattern, show that the intensity at point P would be equal to I0 divided by 4. Okay, so we'll see the B question here. So here x is equal to, we can write this one as a beta by 3. Okay, that is they are given if distance OP equals to 1/3 of the fringe width of the pattern. So it is beta by 3, and the path difference is equal to lambda by 3. Then phase difference is equal to 2 pi by 3. Then I is equal to I0 cos square pi 5 by 2, and I is equal to I0 cos square 2 pi by 3 times 2. I can write 3 times 2 is directly, it is 6. Then I0 into cos square, that is pi by 3, that is 2 and 6 will get cancelled, pi by 3. Then I can write this one as I is equal to I0 times 1 by 4, that is equal to I0 by 4. Third part, in Young's double slit experiment, the slit are separated by 0.5 mm and screen is placed 1.0 meter away from the slit. It is found that the fifth bright fringe is at a distance of 4.13 mm from the second dark fringe. Find the wavelength of light used. Okay. Here the distance of a fifth bright fringe from second dark fringe is given by, we can write that one as x is equal to 5 times lambda into d divided by d minus 3 times lambda d divided by d divided by 2d. Then this is 7 by 2 times lambda d divided by d. Then we'll get the answer lambda is equal to 2 times x into d divided by 7d, which is equal to 2 times 4.13 into 10 to the power of minus 3 times 0.5 into 10 to the power of minus 3 divided by 7 into 1. If I want to simplify, we'll get a lambda is equal to 0.59 into 10 to the power of minus 6 m. which is nothing but 5,900 Armstrong. Derive the relation A sin theta is equal to lambda for the first minimum of the diffraction pattern produced due to a single slit of width A using light of wavelength lambda. Okay, first we will see the diagram of the single slit diffraction. Looks like this. This is the this is one slit and this is the second slit. Okay, and the difference between these two is equal to lambda. Okay, and here the light rays will be coming in this direction. The plate, the angle is equal to theta. Okay, then the difference between the path from diaphragm path difference between the wave from L to N. This L to N, the path difference which is given by A sin theta. Okay, it is equal to A times sin theta. Then when the first minimum is obtained at a path at P, then the path difference is equal to lambda. That means from the diaphragm path difference between the wave from L and N is equal to, we have done that is A sin theta. And when the first minimum is obtained at P, then the path difference is equal to, that is lambda. This difference is equal to the lambda. Okay. Then imagine the slit B divided into two halves. This is a two halves. For each wavelet, from half of the slit as a correspondent wavelet from second half of the slit differing by a path of lambda by 2 and cancel each other. Okay, that means this is one slit and this is another slit, like that. Then condition for the first minimum, that is equal to, we can write it as lambda is equal to A sin theta. We know already this one. For the first minimum, lambda is equal to A sin theta. Then condition B, state with the reason how the linear width of central maximum will be affected if condition 1, monochromatic yellow light is replaced with red light, and second one, distance between the slit and the screen is increased. Okay, then we have that beta is equal to 2 lambda d divided by d, and this condition, the first condition, that is a monochromatic yellow light is replaced with red light, then the central maximum will be affected. It will be increases. This will be increases. Okay, and the second condition, that is distance between the slit and the screen is increased. Yes, this is also increases. This is also increases. Okay, and the third condition, using the monochromatic light of same wavelength in the experimental setup of the diffraction pattern as well as in the interference pattern where the slit separation is 1 mm, 10 interference fringe are found to be within the central maximum of the diffraction pattern. Determine the width of the single slit if the screen is kept at the same distance from the slit in the two cases. Then we have, that is the third case, we have 10 lambda divided by d is equal to 2 lambda divided by a, where a is the width, that is a is equal to d divided by 5. That means we will get 0.2 mm is the width. The width of the single slit is equal to 0.2 mm.